Good day everyone, I am Genesis S. Torres from BS Ed Math Trivia, and my topic is all about 6.2 Application of Normal Distribution. So without further ado, let's begin. 6.2 Application of Normal Distribution. Let me read the definition. So the standard deviation normal distribution curve can be used to solve a wide variety of practical problems. The only requirements is that the variables are normally or approximately normally distributed. There are several mathematical tests to determine whether a variable is normally distributed. So for the formula, it is equal to z minus value minus mean all over standard deviation. Okay, let's try to answer example 6-9. Police Academy qualification. To qualify a police academy, candidates must score in the top 10% on the general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume the test scores are normally distributed. So for the solution, since the test scores are normally distributed, the test value x that cuts off the upper 10% of the area under a normal distribution curve desired. So this is the normal distribution wherein this curve is equal to 1. So work background to solve this problem. Step 1. Subtract 0.10 from 1 to get the area under the normal distribution to the left of x. So we all know that the 1 comes from the normal distribution, which is equal to 1. So we need to subtract it from 0.10. So it is equal to 9.0. Step 2. Find the z-value that corresponds to an area of 0.90 by looking up to 0.90 in the area proportion of table E. So, if the specific value cannot be found, use the closest value, in this case, 0.8990. The corresponding z-value is 1.28. Step 3. Substitute in the formula z is equal to value minus mean all over standard deviation, and solve for x. Instead of using the formula shown in step 3, you can use the formula x is equal to z times standard deviation plus mean. This is obtained by solving z is equal to value minus mean all over the standard deviation. So, how do we come up in this formula? So, we just multiply it both sides by the standard deviation. So, it is equal to z times standard deviation is equal to x minus mean. So, to remove the negative mean here at the left side hand, we must need to add mean both sides. So, by cancellation. So, now it is equal to z times standard deviation plus mean is equal to x. Exchange both sides of the equation. So, you can also use this. X is equal to z times standard deviation plus mean. So, now, by substituting the value in the given formula. So, 1.28 is the corresponding z-value in the step 2. So, next is the value of standard deviation is 20. So, plus the mean is equal to 200, which is given above. And now, let's continue and solve for the value of x. So, by multiplying the 1.28 times 20, it is equal to 225.60 plus 200. And let's add. So it is equal to 225.60. And now the value of x is equal to 226 by rounding up the 225.60. And now, a score of 226 should be used as a cutoff. Anybody scoring 226 or higher qualifies. So now, the lowest possible score to qualify is 226. Next is example 6-10. Systolic blood pressure. For a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. If the mean systolic blood pressure is 120 and a standard deviation is 8, find the upper and lower readings that would qualify people to participate in the study. So, for the solution, assume that blood pressure readings are normally distributed. Step 1. Understand the problem. Find the upper and lower readings that would qualify people to participate in the study. Find the area to the left of the positive Z value of 30%. Find the area to the left of the negative Z value is 20%. So this is the normally distributed. So we are going to find the value of x sub 1 and x sub 2. Step 2. Devise a plan. Let's use the formula x is equal to z times standard deviation plus mean. Step 3. Carry out the plan. To get the area to the left of the positive z value, add 0.50 plus 0.30, wherein the 0.50 is given and the 0.30 is given based on the curve. So it is equal to 0.80. Or if we are going to round it up, so it is equal to 1.00. So the value of 0.80 is 0.7881. So if the specific value cannot be found, use the closest value. In this case, we are going to use the 1.00. So the value of 1.00 in the table Z is 0.8413. So by substituting in the formula, so we are going to find the x sub 1. So x sub 1 is equal to the z times standard deviation plus the mean. So the z is equal to 0.84 times the standard deviation, which is 8, plus 120, which is the mean. So it is equal to 126.72. Next is the area to the left of the negative z value is 20%, or the corresponding z value is 2.00. So next is we need to find the value of x sub 2, wherein the negative z value of the corresponding 2.0 is equal to 0.0228. So, by using the formula, x sub 2 is equal to z times standard deviation plus mean, wherein the z value is equal to negative 0.02 times the standard deviation of the data, which is 8, and or plus 120, which is the mean. So if we are going to use calculator and add it up, it is equal to 119.84. Now that we know the value of x sub 1, which is 126.72, and the x sub 2, which is 119.84. Therefore, the middle 60% will have blood pressure readings of 119.84 is less than x, and x is less than 126.72. Example 6-11. Technology inventories. A survey of 18 high-technology firms showed the number of days inventory they had on hand. Determine if the data are approximately normally distributed. So these are the data: 5, 29, 34, 44, 45, 63, 68, 74, 74, 81, 88, 91, 97, 98, 113, 118, 151, and 158. Step 1. Construct a frequency distribution and draw a histogram for the data. First is to find the range, where range is equal to the higher value minus to the lower value, wherein the higher value is 158 minus the lower value is equal to 5, and it is equal to 153. So next is to find the k, where k is the sum of the class. So 1 plus 3.3 log n, where n is the number of values in data set. So 1 plus 3.3 log 18. So if we are going to use calculator, it is equal to 5.14 or approximately 6. Next is to find the c, wherein it is equal to the r minus k, or c is equal to the sum of the class. So 153 minus 6 is equal to 25.6 or approximately 26. Now that we know the value of k, which is the number of class, which is equal to 6, and c is equal to the sum of class, which is equal to 26. So these are the given data that we are going to use to create a frequency distribution. So class interval is equal to, so let's start with 5 because this is the lower value. So 5 plus 26 is equal to 31. So the frequency is just based on the data above. So 2 kasi dalawa yung pasok sa 5 and 31. Next is 32 plus 26 is 58. So the frequency is 3. So 59 plus 26 is 85. So 5. And 86 plus 26 is equal to 112. So the frequency is 4. So 113 plus 26 is 129, and the frequency is 2. And lastly, we have 140 plus 26 is 166, so the frequency is 2. If we sum up, the frequency is equal to 18. Now that we have a frequency distribution, we can use this to create or draw a histogram for the data. So this is the histogram for the data based on the frequency distribution. Since the histogram is approximately bell-shaped, we can say that the distribution is approximately normal. Step 2. Check for the skewness. X sub bar is equal to 79.5. The median is equal to 77.5. And the standard deviation is equal to 40.5. Using Pearson's index of skewness using the formula PI is equal to 3 times the X sub bar minus median all over the standard deviation. By using this formula, we can now substitute the given value. PI is equal to 3 times the X sub bar, which is 79.5, minus the median, which is 77.5, divided by the standard deviation, which is 40.5. So if we are going to use calculator to multiply and divide it, so it is equal to 0.148. In this case, the PI or person's index is not greater than positive 1 or less than negative 1. So it can be concluded that the distribution is not significantly skewed. Step 3. Check for the outliers. Recall that an outlier is a data value that lies more than 1.5 IQR or interquartile range units below quartile 1, which is or 1.5 interquartile range units above quartile 3. In this case, quartile 1 is equal to 45 and quartile 3 is 98. So how did we come up to get this value? So we just arrange the data from the lower value to the higher value. Then we just divide it into 2. So because the n is equal to 18 if you are going to divide it by 2, so it is equal to 9. So we have the 9 on the left hand side and 9 data on the left hand side. So the 9 data from the left hand side is equal to 5, 29, 34, 44, 45, 63, 68, 74, and 74. We just need to find the center of this data. So the center is 45. So that is the quartile 1. So same as here at the quartile 3. We just need to find the center. So the center is 98. So therefore, or hence, the IQR or interpersons range, to get the value of this, we just need to minus or subtract the quartile 3 to quartile 1. So 98 minus 45 is 53. An outlier would be a data value less than 45 minus 1.5 times the 53. So it is equal to negative 34.5, or a data value larger than 98 plus 1.5 times 53 is equal to 177.5. In this case, there are no outliers. Since the histogram is approximately bell-shaped, the data are not significantly skewed, and there are no outliers. It can be concluded that the distribution is approximately normally distributed. Next example is 6-12. Number of baseball games played. The data shown consists of the number of games played each year in the career of Baseball Hall of Fama Bill Mazeroski. Determine if the data are approximately normally distributed. So these are the data set: 81, 148, 152, 135, 151, 152, 159, 142, 34, 162, 131, 162, 163, 143, 67, 112, and 70. Step 1. Construct a frequency distribution and draw a histogram for the data. So first is to find the range, where range is equal to the higher value minus to the lower value, wherein the higher value is 163 minus the lower value, which is 34. So it is equal to 129. Next is to find the k, where k is the number of class. So 1 plus 3.3 log n, where n is the number of values in dataset. 1 plus 3.3 log 17. So if we are going to use calculator, it is equal to 5.06 or approximately 6. Next is to find c, where c is the sum of the class. So it is equal to the range divided by the k, where r is equal to 129 and k is equal to 6. So it is equal to 21.5 or approximately 22. So now that we know the value of k, which is the number of class, it is equal to 6, and c is the sum of the class, which is equal to 22. Now, these are the given that we are going to use to create or construct a frequency distribution. So, the class interval is equal to 34 plus 22 is 56. And the frequency that kabilang or pasok sa 34 to 56 is 1. So next is 57 plus 22 is 79 and the frequency is 2. 80 plus 22 is 102 and the frequency is 1. 103 plus 26 is or plus 22 is 125 and the frequency is 1. 126 plus 22 is 148, so the frequency is 5. So 149 plus 22 is 171 and the frequency is 7. If we are going to add it up, all the frequency, it is equal to 17. Now that we have the value or the frequency distribution, we can come up in this data to create or draw a histogram for the data. So this is the histogram for the data. The histogram shows that the frequency distribution on is somewhat negatively skewed. Step 2. Check for the skewness. X sub bar is equal to 127.24, median is equal to 143, and standard deviation is equal to 39.87. Using Pearson's index of skewness, using the formula PI is equal to 3 times the X bar minus median all over the standard deviation. By using this formula, we can now substitute the given data. So PI is equal to 3. So the value of the X bar is equal to 127.24 minus the value of median, which is 143, and the value of the standard deviation, which is 39.87. Now, if we are going to use calculator, it is equal to negative 1.19. Since the Pearson's index or PI is less than negative 1, it can be concluded that the distribution is significantly skewed to the left. Step 3. Check for the outliers. In this case, quartile 1 is equal to 96.5 and quartile 3 is equal to 155.5. So how did we come up in this given value? We just arrange the given data from the lower value to the higher value. Then we just find the center of the given data. So the center is 143. Then we just divide it into 2. So the quartile 1 is given 34, 67, 70, 81, 112, 130, 135, and 142. So we just need to find the center of this 6. So the center is 81 and 112. So if we add it up, and divided by 2, so the quartile 1 is equal to 96.5. Same as here at the right side hand. So the given is 148, 151, 152, 152, 159, 162, 162, and 163. The middle is 152 and 159. If we added up and divided by 2, the quartile 3 is equal to 155.5. So if we are going to get the interquartile range of these two, we just need to minus the quartile 3 and quartile 1. So 155.5 minus 96.5 is equal to 59. Any value less than 96.5 minus 1.5 times 59 is equal to 8 or above. So 155.5 plus 1.5 times 59 is equal to 244 is considered an outlier. There are no outlier. So in summary, the distribution is somewhat negatively skewed. So that's the coverage of my topic. Thank you.